Hello everyone, our group will introduce about the application of regular expression matching. In this presentation, we will cover from introduction to conclusion as follows. Let's start from what is deep packet inspection. DPI is one of the methods for network intrusion detection. Network is getting complicated. The importance of DPI is getting bigger as it works as firewall, detecting the signature of intrusion cover all of the network layer. Then, what would be the relationship between automata and DPI? This figure shows how DPI apply regular expression matching in its system. DPI construct the finite automata with the regular expression input and then detect the attack based on the train signature data.
Now, I'm going to talk about problems of standard DFA and NFA. DPI get regular expression and convert to NFA and DFA, but when we think of the features of NFA and DFA, there are some limitations as you can see here. The figure shows their result in worst case. For this reason, some compression DFA methods are proposed such that D2FA, HFA, and XFA. The first compression DFA method is D2FA, which is similar to DFA structure. D2FA make default transition to reduce transition to improve the efficiency. As a result, D2FA can reduce transition as compared with DFA. Second, HFA is combined with advantages from different automata, which include data structure size from NFA and memory bandwidth from DFA. Third, XFA simplified the states of DFAs to reduce states, and then the simplified DFA state will be composed. However, D2FA, HFA, and XFA cannot improve the efficiency as much as the researcher wants. This is because they could not reduce the state and transition enough. Therefore, U algorithm and improved group algorithm are created in order to reduce more state and improve the efficiency.
At 2008, you proposed group algorithm presented the way how to group the regular expression constructor graph. The author proposed the definition of interaction. It means that two patterns interact with each other if their composite DFA has more state than the sum of the two individual ones. This figure shows the progress of group algorithm. First, construct the graph with vertex represent each regular expression and the edge for interaction. Your algorithm found the vertex have the lowest number of edges with the group and then add it into group and delete it in the graph. Repeat this until the group exceeds the memory limitation. If it exceeds, the algorithm creates a new group for other ungrouped regular expression. Therefore, engine can obtain more efficient state by converting each patterns into the group.
But U algorithm can easily trap into local optimum because it only counts the number of edges and group it. It reduced the state number but couldn't improve the efficiency. In this year, new method is proposed called improved grouping algorithm, which is not only reduce the state numbers but also improve the transaction efficiency. The author introduced new concept, expansion coefficient, which can be calculated by the state number of DFA. This algorithm uses different approaches based on the value of the coefficients divided into three sections as follows. The figure below shows the example graph constructed among the 5 regular expressions where the weight of the edges represented the expansion coefficient. IJ finds which vertex has the lowest EC value associated with group. So in this figure, vertex C will be added into group 0 and removed from the graph, and algorithm will recalculate the all EC value in the graph and repeat to find other vertex. Let's see what is different between your algorithm and IGA. First, IGA uses the expansion coefficient to calculate the relationship between the regular expressions, while U algorithm is simply based on the number of connections. Second, IGA algorithm updates the expansion coefficient after grouping, while the U algorithm does not. The second table shows the comparison experimental result. As you can see, IGA improved efficiency more than 18%. So far, we presented the advanced concept of DFA and NFA and their applications, but we think there is still room for improvement of finite automata algorithms cause IJ couldn't meet the goal for storage consumption and time efficiency that researchers expect.